today is an introduction into algebraic expressions and looking at writing and evaluating expressions. So first of all, some key vocabulary here. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. So instead of numerical expressions that just have numbers and operations, we now have symbols as well. Terms are the parts of an algebraic expression. And then the variable is the symbol that represents one or more numbers. So those are those symbols that you see in algebraic expressions. Variables are typically they're typically letters. Any letter of the alphabet can be a variable. Then we have the coefficient. This is the numerical factor of a term that contains a variable. Basically, the coefficient is the number that is multiplied by a variable. That's where that word factor comes in. It's multiplied by a variable. And then you have the constants. Those are the terms without a variable, so just the numbers. So let's look at an example of identifying the parts of the algebraic expressions. So down here we're going to identify the terms, the coefficients, and the constants. So in our first example we have 5x plus 13. That's how we would read this. 5x plus 13. X is now going to be seen as a variable when we're working with algebra. That x is what's called the variable. So that's why we've talked about using other symbols to show multiplication rather than an x, because we'll see it as a variable a lot. So the terms are the parts of our algebraic expression. So 5x would be one part or one term. And then 13 would be another part or term. So there are two terms. They're separated by the operation. The coefficient, remember, is the factor or the number that's multiplied by a variable. So here's my variable x. That means 5 is multiplied by x. When you have a number next to a variable like this, 5x, that's the same as 5 times x, a number next to a variable with nothing in between. So this means 5 times x, which means my coefficient is 5, the number I'm multiplying by that variable. Then the constant is just the term without a variable. 13 doesn't have a variable, so we would say it's a constant. Okay, let's look at another one. This one is 2z squared plus y plus 3. So we have three different terms here separated by the operation. So our terms would be 2z squared, all of that is one term. Y would be one term. And then 3 would be another term. We actually have two variables in this expression. Z and y both would be the variables in this case. We have two different variables. So we should have two coefficients if we have two variables. So the coefficient, remember, is the number multiplied by the variable. So in this case, 2 is multiplied by the z squared. So 2 is a coefficient. Over here we have a y, and it looks like there's nothing multiplied by the y. But if we think about it this way, y is going to be the same as 1y. That's a 1. Because 1 times any number is itself, so 1 times y is just going to give us y. So the coefficient here is actually 1. And then 3 doesn't have a variable, so it's our constant. Go ahead and try these three down here. Identify the terms, coefficients, and constants. And you can just label t, coefficient, and constant this way. Once you've done all three, unpause your video and check your work. Okay, go ahead and check your work there. I do want to point out on number 3, notice that I put none next to the constants. I'm not adding or subtracting anything that doesn't have a variable, so I have no constants. Okay, let's turn our page over and go ahead and look at writing algebraic expressions now that have exponents, kind of like we saw the z squared on the first page. So if we write an expression using exponents, it's just like writing an expression with exponents with numbers as well, like 2 to the 4th power, 3 to the 2nd power, and so on. We're going to do the same thing with our variables. So in this case, I have 1, 2, 3, 4. D is being multiplied by itself 4 times, so I would put D to the 4th power. Okay. Over here, I have 1 and 5/10. That's being multiplied by H, and I have 3 H's. So I would have 1 and 5/10 times H to the 3rd power. Go ahead and do 4 and 5, please. And check your answers to 4 and 5. And we'll move on to evaluating expressions. So now when we evaluate an algebraic expression, we're going to use something called substitution. So substitution, it's just like what it sounds. When you have a substitute teacher, you have a teacher that you are putting in place of your permanent teacher. So we're going to do that. We're going to take a number and substitute it in for the variable. So in this expression, we have k plus 10. And it says evaluate that, or find the value of, when k equals 25. So what I'm going to do is rewrite the expression, but instead of writing k, I'm going to put 25. So 25 plus 10, and we know that's 35. That is it. I evaluated that algebraic expression. Let's try it over here. Evaluate 4 times n when n equals 12. So here's my expression. I'm going to rewrite that, but instead of n, I'm going to put 12. So I get 48. Go ahead and pause your video and try 6 and 7. Check your work on 6 and 7, and we will move on. Now we're going to look at what happens when you have 2 variables and you go to evaluate an expression. So in this case, our expression is a divided by b. So I'm going to rewrite that expression, a divided by b. When a equals 16, and here's a typo here, that should say when b equals 2/3. So we're going to rewrite the expression. Instead of a, I'm going to put 16. And instead of b, I'm going to put 2/3. So at this point, I'm just using those 2 values because they are telling me what a equals and what b equals. Then this just becomes a problem that we've solved before. Remember, when you're dividing by a fraction, you multiply by the reciprocal. So now I have 16 times 3/2. I'm going to go ahead and cross simplify. So I'm just left with 8 times 3, or 24. Go ahead and pause the video and try the 4 below. All right, check your work on 8 through 11. One common mistake I see on problems like number 11, 24 times 8, when we have problems like this, P times Q, we tend to put the 24 and then the 8 and think our answer is 248. Remember, when you have 2 variables next to each other or a number next to a variable, that does mean to multiply. All right, the next thing we're going to do is evaluate expressions now that have 2 operations. So this will be using our order of operations. So in my first example, 3x minus 14, we're told x equals 5. So that means 3 times x minus 14. So we're going to use substitution again, and I'm going to rewrite my problem, but instead of an x, I'm going to put 5. So remember, don't just put the 5 and assume it's 35. That means 3 times x, so I need to have this as 3 times 5, and then minus 14. So I have multiplication and subtraction. I'm going to do the multiplication first. So 3 times 5 becomes 15. And now I have 15 minus 14, so that becomes 1. All right, let's look at letter B. This should be z squared plus 8.5, another typo. But z is going to be 2. So I have z squared plus 8 5/10. I'm going to rewrite this and put a 2 instead of z. So I have exponents and I have addition. Let's do our exponent first. So 2 squared becomes 4. So now I have 4 plus 8 and 5/10. So 4 plus 8 is 12, and then I still have the 5/10. 12 and 5/10. Go ahead and pause your video and try these 4 below. Y will be 6 in all of those. All right, go ahead and check your work on 12, 13, 14, and 15. Hey, last problem here. Let's go ahead and look at this in a word problem. So down here, you're saving money to buy a new skateboard, and you begin with $45, and then you're going to save $3 each week. Here's the skateboard. It's $125. So our expression, 45 plus 3W, gives the amount of money you save after W weeks, however many weeks that W represents. So this means you have $45 and then $3 each week. That's how that expression reads. So we want to know how much money you will have after 4 weeks, then 10 weeks, then 20 weeks. So we're going to organize this in a table down here. And again, we want to look at 4 weeks, and then 10 weeks, and then 20 weeks. So that's my number of weeks. We're going to substitute that in here for the W. So I would have 45 plus 3 times 4. So that's going to turn into 45 plus 12. That means after 4 weeks, you now have $57. Let's look at 10 weeks. So 45 plus 3 times 10. That's going to be 45 plus 30. That means after 10 weeks, you now have $75. Now let's look at 20 weeks. 45 plus 3 times 20. So 45 plus 60 means you now have $105. So after 20 weeks, can you buy the skateboard? I'm going to restate my question. After 20 weeks, and it looks like after 20 weeks, you have $105. But the skateboard costs $125. So, if I explain that, you have $105, so you cannot buy